Hello friends, welcome to video lecture. I'm Kirti, taking your chemistry lectures. Our idea is stay home, stay safe and enjoy chemistry. Our today's topic is chemical reactions and equations. Do you know what is around us? Right, it's a matter. What is matter? Everything around us is matter. The matter is made up of atom and molecule. So we can say that the matter is a combination of atom and molecule. Let's learn more about the matter. States of matter. The matter is divided into three states: solid, liquid and gaseous. What is basic difference between solid, liquid and gaseous? It is arrangement of atoms and molecules. In solids, atoms are very close to each other. In liquid, they are separated by small distance, and in gases, they are far away from each other. In solid, as the atoms are very close to each other, therefore, solid having fixed shape, they are rigid and they cannot be compressed. In liquid and in gases, atoms have free space, therefore, they can move. Therefore, they are having no fixed shape and no volume. As in gases, the atoms are far away from each other, therefore the gases are highly compressible, but the liquids are not. Properties of matter. There are two types of properties: physical properties and chemical properties. Let's learn about physical properties. Physical properties are those properties which can sense by our senses. For example, by eyes, we can see size, shape, color. By touch, we can understand hotness, coldness and texture. By nose, we can understand smell or odor. We can understand taste. So, these are the physical properties because this can be sensed by our senses. Physical properties are size, shape, color, odor, melting point, boiling point, density, weight, mass. These are some physical properties. Chemical properties: flammable, pH, corrosion and toxicity. These are some chemical properties. Now let's learn about physical changes and chemical changes. Physical changes. Let's see some physical changes. Change in state of matter. First is melting of ice. Second, melting of candle. Vaporization, contraction and freezing are also physical changes. Thermal expansion is also physical change. Change of size or shape, that is crumbling of paper, this is also physical change. So from this example, we can say that the physical changes are those changes in which the physical properties are changing. So the physical processes are reversible. That means it can be interconvertible. The water can be converted into water vapor. Water vapor can be converted into liquid water. Chemical changes. So let's see some example of chemical changes. Digestion, corrosion, that is rusting of iron, formation of curd and ripening of fruit. So from this example, we can say that the chemical changes are those changes in which physical and chemical properties are changing. In a chemical change, atoms or molecules arrange in a such a way that a new substance is formed having a different physical and chemical property. Chemical changes are irreversible. That means we cannot reverse the process by simple physical means. Chemical process is a one-way process. That means When we get a curd from milk, we cannot get milk from curd again. Now let's revise the difference between physical and chemical changes. Arrangement of molecule. In physical change, the arrangement of molecule can changes, but the composition of substance remains same. In chemical changes, the composition of substance completely changes. Reversibility. The physical changes are reversible while chemical changes are not reversible. Type of changes. The physical changes are temporary while chemical changes are permanent. Next is energy production or absorption. In a physical change, there is no any kind of energy absorption or evolution takes place, while in a chemical change, absorption and evolution of energy can take place. Effects. In a physical changes, it affects only a physical properties. Like for example, in this case, only size and shape can changes. While in a chemical change, both the physical and chemical properties are changing. For example, for physical changes, melting of ice, vaporization, crumbling of paper, these are the example of physical changes. While in a chemical change, digestion, respiration, rusting, ripening of fruit, these are the example of chemical changes. Chemical reaction. So whenever chemical changes are there, we can say that a chemical reaction takes place. Now, the question is, how we come to know that chemical reaction occur? For this, let's do some activity. In this activity, we have burned magnesium in presence of air, that is oxygen. Magnesium is converted into white powder, that is called as magnesium oxide. In this, magnesium is burned with dazzling white flame and converted into white powder called as magnesium oxide. Suppose zinc react with hydrochloric acid and converted into zinc chloride with evolution of hydrogen gas. In this reaction, temperature increases. From this, we can conclude when there is a change in state, change in color, change in temperature, and evolution of gas takes place, then we can say that the chemical reaction occurring. Chemical equation. So we can represent the chemical reaction in the form of chemical equation. It is shortest form of chemical reaction. Let's understand how to write chemical equation. To understand this, let's take a general example. Let A react with B and it gives out C and D. So A and B are known as reactant. C and D are known as products. So reactant are always written on left hand side and they are separated by plus sign. Products are always written on right hand side and so separated by positive signs. Reactant and product are separated by an arrow. Let's take an example. In in activity, we have seen that magnesium combined with oxygen and converted into magnesium oxide. So, we can represent this reaction in word, that is magnesium combined with oxygen converted into magnesium oxide. This equation we are denoted in word form. We can also represent an equation in a shorter form. In a shorter form, we are always using a symbol or chemical formula. For magnesium, the symbol is Mg. For oxygen, the symbol is O2, as the oxygen is always we are representing in a molecular form converted into magnesium oxide, and the formula of magnesium oxide is MgO. While representing a chemical equation, we also represent the states of the compound or a molecule or element. For example, here magnesium is in a solid state, so we can represent as S in bracket. Oxygen in a gaseous form, so we can written in a bracket as G, converted into MgO, which is in a solid form, so denoted as S in a bracket. Similarly, let's take another example, that is formation of water. In a formation of water, hydrogen combined with oxygen converted into H2O. Here, hydrogen, symbol of hydrogen is H2, as hydrogen occur in nature in a molecular form. Oxygen is O2 and the formula of water is H2O. In a bracket, for H2 we are written G, that means hydrogen in a gaseous form. For oxygen, in bracket we are written as G, that means the oxygen in a gaseous form converted into H2O. H2O is in a liquid form, therefore we have written L in a bracket. Balancing chemical equation. Let's take one example. Magnesium combined with oxygen converted into magnesium oxide, that is Mg plus O2 gives rise to MgO. But is this reaction is correct? Yes, this is not correct equation. To write a correct equation, we have to follow law of conservation of mass. The law states that the mass of reactant is always equal to mass of product. Here on left hand side there is one magnesium, and on the right hand side, that is on the product side, one magnesium. But if we see carefully, on left hand side there are two oxygen, but on the right hand side there is only one oxygen. Therefore, we have to balance this equation. So, for balancing this equation, we cannot increase oxygen because the molecular formula of oxygen is O2. So, therefore, I am writing here as 2 Mg combined with O2 gives rise to 2 MgO. So, in this equation, on left hand side, 2 magnesiums are there, and on the right hand side, 2 magnesium. And now we have balanced oxygen also. So this is a balanced chemical equation. Let's learn stepwise how to balance a chemical reaction. For example, corrosion of iron. In this reaction, Fe react with H2O and converted into iron oxide. So for this reaction, we can write equation as Fe plus H2O gives rise to Fe3O4 plus H2. Step 1. First, make boxes to all compound. Remember that we cannot make any change in the boxes, that is in a chemical formula. Step 2. List the number of atoms of different element present in a different compound. So here we have 1 Fe in reactant and 3 Fe in product. Similarly, we have 2 hydrogen in reactant and 2 hydrogen in product. 1 oxygen in reactant and 4 oxygen in product. Step 3. It is easy to start with a compound having maximum number of atoms. In that compound also, we choose the element which is having more atoms. So here in this example, Fe3O4 is the compound having maximum number of atoms. So we can choose compound either from reactant or product. In Fe3O4, oxygen atoms are maximum in number. So to balance oxygen, we again write the number of atoms which are present in the reactant and product. So in reactant, we are having 1 H2O, that means 1 oxygen is there. In product, Fe3O4, that means we have 4 oxygen. Now we have to balance oxygen and therefore we have to multiply by 4 on reactant side. That is, we have to multiply by 4 to H2O. So the equation will become Fe plus 4H2O gives out Fe3O4 plus H2. This is partial balanced equation. Now step 4. Fe and hydrogen atoms are still not balanced. So pick the element having the number of atom maximum in it. So let's balance hydrogen first on the basis of this criteria. So in the reactant now we have 4 H2O, that means 8 hydrogen, and in product we have 2 hydrogen. So to balance the hydrogen, we have to multiply on product side by 4. So we have to write 4H2 on product side. So now our equation is Fe plus 4H2O gives out Fe3O4 plus 4H2. Now only Fe remains unbalanced. So again list how many Fe are there in the reactant and product. So now in the reactant we have only 1 Fe and in product we have 3 Fe. We have to multiply by 3 on the reactant side. So the equation becomes 3 Fe plus 4H2O gives rise to Fe3O4 plus 4H2. This is a balanced equation. I would like to teach you a trick which is based on mathematics. So let's take simple example first. We try to solve same equation here. So we have Fe plus H2O gives rise to Fe3O4 plus H2. Let's assume we have AFE, BH2O, C molecule of Fe3O4 and TH2. According to law of conservation of mass, number of atoms of element on the reactant side must be equal to number of atoms of element in product side. Therefore, AFE must be equal to 3CFE, which means A is equal to 3C. Similarly, we can write 2B equal to 2D for hydrogen and B is equal to 4C for oxygen. So we have B is equal to D. Let A is equal to 1. Then C would be 1 by 3 from above equation. B would be 4 by 3. Similarly, we will have same value. If we put this value in equation, we have Fe plus 4 by 3 H2O gives out 1 by 3 Fe3O4 plus 4 by 3 H2. As here the number is fraction, therefore we have to convert it into integer. So multiply by 3 to the whole equation. We'll get 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2, which is similar to the above equation. So you can solve the problems by any method. Please remember, a real method is trial and error method. Therefore, it takes time to solve equations. Second method is a mathematical method and easier and reliable and not require much time. I hope you have enjoyed the lecture. I am giving assignment based on this lecture. Please solve. Thank you.